one final topic for graphs. So this is a new type of graph called directed graph. So a directed graph G, which consists of V and E. So it has V, which is a set of vertices, and E, which is a set of edges. Now, in a directed graph, each edge is an ordered pair U comma V, not a set U comma V. So what's the difference? Well, in a set, the order doesn't matter. In a pair, the order matters, right? It's an ordered pair. So the idea is that it represents arrows, right? Directional connections from vertex to vertex, as opposed to just, two-way streets. So for example, there's an arrow from C to B. So you'd have a pair C comma B, right? But so let's actually write this out. So let's actually write out the sets. So here V is going to be the set A, B, C, and D. And then the set of edges is going to be a set of ordered pairs. So we have an ordered pair A comma B. We have an ordered pair B comma A because there's an arrow going the other way too. We also have B comma D. All right, we also have, let's see, going to C, we have C comma B, and we have C comma D. Okay, but notice we don't have, let's say, D comma C, right? Because there's an arrow going from C to D, but not the other way. So we only have C comma D, but not D comma C. How do we represent this in using our graph data structures? So here it's the same idea, similar idea, but here let's show you. So for A, so A has an edge going from A to B. So we put B here, and that's it, right? Now B has an edge going to A, so we put A here. And also B has an edge going to D, so we put D here. Now, there is an edge from C to B, but that's not starting from B. So the point is we're only including things that B points to. So B points to A, B points to D. Right? So we have A and we have D here. But B does not point to C. So we do not put C here in this list. Now, moving on to C, C points to B and C points to D, so we have those two. There are some things that point to D, but D doesn't itself point to anything, so we leave this blank. And then for the adjacency, for the matrix. So let's see. So this is nothing. A to B is yes, and that is, and the rest is 0. Now B to A is yes, right? So here again, the order matters. So B to A there's an arrow from B to A. Is there an arrow from B to B? No. Is there an arrow from B to C? Well, there's an arrow from C to B, but not from B to C. The order matters. So is there an arrow from B to C? No. So this is a 0. Is there an arrow from B to D? Yes, so there's a 1. Next, going on to C. Is there an arrow from C to A? No. Is there an arrow from C to B? Yes. Is there an arrow from C to C? No. Is there an arrow from C to D? Yes. Now, finally, D. Is there an arrow from D to anything? No. There are some arrows pointing at D, but starting from D, going out from D, there is nothing. So this is all 0s. All right, so that's directed graphs. So that's the end of the topic of graphs. Of course, you might think this is totally pointless, totally, totally artificial, and pointless basically. But you'll see, as you, if you take like a course like analysis of algorithms, if you take a course like artificial intelligence, maybe some other courses, you'll see some applications of graphs. And more generally in sort of, there are a lot of applications of graphs in computer science and even beyond in physics and other fields. So but of course, we're just really talking about the very basics here, but I hope you get to learn some more about it in the future.